Hi, for this video, we will look at the digestion of protein. Your lesson discussed what happens when you eat an egg. Let's take a closer look at that and actually watch what happens. The teeth begin the mechanical breakdown of the large egg pieces into smaller pieces that can be swallowed. The salivary glands provide some saliva to aid swallowing and the passage of the partially mashed egg through the esophagus. The mashed egg pieces enter the stomach through the esophageal sphincter. Then the stomach releases gastric juices containing hydrochloric acid and the enzyme pepsin, which initiate the breakdown of the protein. When protein-rich foods like the egg enter the stomach, they are greeted by a mixture of pepsin, an enzyme, and hydrochloric acid. The acid of the stomach facilitates the unfolding of the remaining proteins that weren't completely denatured during cooking. It helps break down the protein aggregates formed from coagulation during cooking. The activity of pepsin is best in an environmental pH of 1.5 through 3.5 that denatures proteins within food. Pepsin cuts proteins into smaller polypeptides and their constituent amino acids. When the food gastric juice mixture called chyme enters the small intestine, the pancreas releases sodium bicarbonate to neutralize the hydrochloric acid. This helps to protect the lining of the intestine. Pepsin, which is secreted by the cells that line the stomach, dismantles the protein chains into smaller and smaller fragments. The pancreas secretes digestive juices that contain more enzymes that further break down the protein fragments. The two major pancreatic enzymes that digest proteins are chymotrypsin and trypsin. The cells that line the small intestine release additional enzymes that finally break apart the smaller protein fragments into the individual amino acids. In the lower parts of the small intestine, the amino acids are transported from the intestinal lumen through the intestinal cells to the blood. This movement of individual amino acids requires special transportation proteins and the cellular energy molecule adenosine triphosphate, ATP. Once the amino acids are in the blood, they are transported to the liver. As with other macronutrients, the liver is the checkpoint for amino acid distribution and any further breakdown of amino acids, which is very minimal. Recall that amino acids contain nitrogen, so further catabolism of amino acids releases nitrogen-containing ammonia. Because large amounts of ammonia can be toxic, the liver transforms it into urea, which is then transported to the kidney and excreted in the urine. This happens with all the protein you eat, and with each meal or snack, the process starts over again.